Hello, exceptional students of Mrs. Whitney's. Today we're going to talk about the distributive property. You did this in 6th grade, but we wanted to give you a little bit of a refresher, and Mrs. Carson has a wonderful example about how to explain the distributive property using twins called Billy and Sally. So we're going to pretend that we have two twins, and their name is Billy and Sally. And so here is Sally. Mrs. Carson gave her cute little hair. And here is Billy. And Billy has some hair. And maybe some eyeballs. Both eyeballs. And a little smile. Same with Sally. So it's Billy and Sally's birthday. And we need to give them a present. So here's Billy and Sally, and we have this present, and we need to give the present to both Billy and Sally. So a lot of times when you're doing the distributive property, you forget and you only give the present to Sally. Problem is, now Billy doesn't have a present, and since they're twins, they have the same birthday, and he's mad. And Mrs. Carson says that Billy is kind of not the nicest person. You wouldn't want to meet him in an alley. And you certainly wouldn't want to forget to give him his birthday present. So don't forget, you have to give his birthday present to both Sally and Billy. So you distribute that present to both of them. So in the end, we have Sally here. And she has a present because you distributed it to both of them. That's a bow, by the way. And then you have Billy. And don't laugh at my artist abilities. I have none. This is why I'm a math teacher and not an artist. And Billy is really happy because you didn't forget him and you gave him a present too. So let's see how this really works in math. So if we have 2 times 3x subtract 4. So we're going to take that 2 and it gets distributed or multiplied. Distribute is really kind of a fancy word for saying multiply everything that's inside the parentheses. So you're going to multiply 2 times everything inside the parentheses. So 2 times 3x, you multiply the 2 and the coefficient, which is 3, so you get 6x. Now here's where the thing gets a little bit weird. Remember what I was telling you just a little bit ago, where you had to take the negative sign or the operation and apply it to the term to the right? So this is really a negative 4. If we added the opposite, we'd end up with 3x plus a negative 4. So that operation goes with the 4. Sometimes you've heard me, when you've asked me, is that a subtraction or a negative? And I've said, well, they're kind of really both. So here's where that's really going to come into play. So it ends up being 2 times a negative 4. Positive times negative gives me a negative. So it is 6x subtract 8 because you distribute that 2 to both Sally and Billy. Okay, let's try another one. We have negative 3. We're going to multiply that times 2a and times 3. Everybody's positive inside the parentheses, so that's okay. But this negative sign goes with the 3 on the outside. So it's negative 3 times 6 times 2a. So negative 3 times 2 is negative 6. The a is there. Negative 3 times 3. A negative times a positive is a negative. So it is negative 6a subtract 9. Now, often you guys are going to ask me, is it okay to write it like this? And I'm going to tell you, yeah, it is, because those two expressions are equivalent. You're eventually going to stop writing this, only because, as my favorite saying goes, mathematicians are lazy, and that's a lot of extra characters we really don't need. Okay, one more tricky one. Now this one might blow your marbles, but let's think about what this really is. If I have a negative sign outside the parentheses, it means that really there's kind of a negative 1 hiding out there. Remember, we're lazy, so we don't write the 1. So we can distribute that negative 1 and multiply it by everybody inside of the parentheses. So negative times a positive 4 would be negative, so it would be negative 4z. Negative times a positive is negative, so it would be negative 4z subtract 5. So remember, when you're distributing, you're multiplying whatever's on the outside times everybody that's on the inside. And if I had 3 terms inside, you'd multiply it by all 3 of them. So just a quick refresher on how the distributive property works.